Welcome everyone to Get Cloudified. This is our first video, and today's topic is all about introduction to cloud computing. If I was in an elevator and someone were to ask me what is cloud computing, I just have few seconds to answer. Right? So I would rather go this definition. Cloud computing is delivery of computing as a service rather than a product. Computing traditionally has been a product. Okay, so what is the difference between a service and product? We'll see now. Okay, so similarly, 100 years ago, electricity was a product. It is uncommon for a big companies to have a VP level person just for an electricity. Now, this may sound strange, right? But in early 1900s, if you want to start a factory or an office and you need an electricity, right? So now computing electricity was in the same state as of computing is now today. Okay, which means if you wanted to use electricity in early 1900s, you would need to buy generators to produce enough electricity, or you need to get contract with the power plant companies and make sure they give you enough electricity. Hence you need a VP level person to manage your electricity infrastructure to make sure it doesn't become the bottleneck in operating your factory. Okay, see, in the last 100 years we have solved this problem. Like, so now the VP level person is not needed for an electricity. How? Any cases, we have made centralized power generation and we have a grids that will distribute it everywhere. Okay. Now, if someone has to open a factory or office, getting electricity is not usually the problem in most of the countries. Electricity has moved from a product based to a service based. Okay. So, cloud computing is also doing the same thing with computing. Okay, so right now computing is very product based. Okay, so cloud is trying its best to move the computing from a product based to a service based. Okay, so now let's say we have developed an application. Okay, and I want to release it to the world so that people can come and use this application from anywhere. But first, we need to figure out how much servers I need. Okay, what type of database I'm going to use and how much amount of storage I need. Okay, so underestimating might create way too much load on those servers. Okay, your computing servers will start to fail, your database starts loading, and your storage stops working because there is no space. Okay, also overestimating will result in a wasted service capacity. Okay, so this server will also incur you an invoice that will get you a bill also. Okay, so let's say we now decided to get 10 servers. We have to first go and get those servers. Okay, this could be either a local or a remote server. In case of a local server, we have to go out, right? We have to buy those servers, wait for them to get delivered to our space. We have to configure them. Then we have to deploy our application. Okay, in case of a remote, we have to go to some hosting company, asked for those servers. Okay, we have to sign a contract with them, then we will get access to the servers and then deploy our application on them. Okay, so another advantage of electricity being a service is uh, we don't have to worry about it as long it is there, right? So if you take an example, this video, you are watching this video, you are consuming electricity by watching this. Okay, but you would never notice until it, as long as it is on, right? So but if electricity goes away, then we will notice, then it becomes a problem, right? So computing is something similar in this case. If you deploy an application and if your users are using the application, they don't care about what hardware you are using, right? As long as they are getting the service. But if your hardware goes down, then they will notice, as you can already see that there are a lot of advantages to the services comparing to the products. Okay, so now they will question what is the underlying hardware you are using, that and all, that will become a situation here. Okay, so time is not a far away. We can get a data centers the same way as we are getting an electricity. Okay, we have to just plug into a socket and we will get our data centers in the same way you are getting electricity from the grid. Okay, so now we will see the evolution of the software. Okay, so first, mainframe era. Most companies had their corporate IT infrastructure on mainframes until early 2000s. Mainframe were how companies installed and ran their application. Okay, so there are a lot of drawbacks, right? So, but they also have some advantages in it. Okay, there are two main components in software, right? So one is the data and the other is application. Okay, in mainframe both your data and your application were on the same machine. You have you have a lot of dumb terminals all over from where you can log in and access your application. Okay, so all of these dumb terminals have to be in a single building. Okay, where the mainframe is being situated. For an example, you are using some word processor. Okay, and you are working on some document in one of those dumb terminals. After finishing a part of a document, you have to leave. Okay, when you return you could use a different terminal. Okay, after coming back you could use a different terminal. So this was fine when there is no data stored on the terminal itself. Okay, here the data has been stored in the mainframe. As long as it is in the mainframe, you can get access from any of those dump terminals. Correct. So no matter whether you where you logged in. Okay. So the data and application was always there. Right. So the second advantage, the mainframe is it is a single point of management. Okay. Your software management has been centralized. So now let's say you require a word processor. All you have to do it is install it on the mainframe and all the users would get it. If you had 20 dumb terminals, 40 dumb terminals, 100 dumb terminals, all you have to do it is install it on a main terminal itself. Okay, so now the main advantages are the data and application were on the single mainframe. Okay, so the software management has been centralized. The same vendor will provide both the hardware and the software. Okay, because there is only one hardware and there is only one software, you are going to use that software in only that hardware alone. Okay, so this is the basics for a mainframe, how it has been working. Then we are moving to, right. So, sorry, the vendor is also responsible for maintaining your hardware and software. Okay. So then come after the mainframe, we are entered into a PC era. Okay. So PCs brought with huge advantages. PCs provide you the ability to give a person his isolated computing resources. Okay, which allowed them to work independently. Unlike mainframes, there were a lot of contention for resources. So if a person was doing something very CPU intensive on mainframe, other people on the same mainframe would get affected. Correct? So this issue was solved by PCs as everyone have their dedicated processing capacity. Okay, but with the same advantages, there came the problems. Now your data and applications are no longer centralized. Okay, so now let's say you have to install a word processing application. Okay, you have to go to each and every of those PCs, I mean computers. Then you have to install the software. Let's say you write a document on one of those servers. Okay, and you go out for lunch. Now you have to log back into the same machine to continue your editing your document. You cannot just log in any machine and get your document unlike you do it in the mainframe. Okay, so that's your application and your data is not bound by the PC and they are no longer centralized. Okay, so the PC manufacturers and software manufacturers became independent in PC era. Okay, in mainframe days, they used to get both provided by the same company. Okay, so this separation between the hardware provider and the software provider, gave much opportunity to the companies to start providing their own operating systems and application software. Okay, so to enter into the market. This also resulted in IT managers having to manage both the hardware and the software. If something fails on the software side, you would have to call the software vendor. Okay. If something fails on the hardware side, you would have to call to a hardware vendor. PCs made software into a product. Okay, softwares are now sold in series. Okay, and Microsoft made a fortune doing just this. They are just selling softwares on series. So from being centralized, software becomes a product. So client is now responsible for managing this software. Okay, so after this PC era, we came in a post PC era. So from the PC era, we have moved into the current era, which is most called as post PC era. One of those characters of post PC is the range of devices. The Microsoft once have a statement many years ago, like one PC in every home and Microsoft products on each and every PC. Is that true anymore? Not really. Every home have multiple computers, a desktop, a laptop, a couple of smartphones and tablets. Another characteristic is that everything is connected. About 10 years back, it took some effort to get to an internet. In most of the countries, it is now impossible to imagine a place without a network connectivity, at least 2G or 3G networks. Okay, so there are a lot of devices connected at all the time. So the problem of disjointing data and application, whether your application and data are not centralized, is severely compounded. Okay, so there is a huge problem arising on this. So let's say you're writing a document on a tablet. Okay, you have to reach your office. Now you want the same document on your office machine because the data is because you have to use so many devices. Okay, the data has to be everywhere. We are at various points in time, and we want our application and data to be centralized. So this is why a lot of companies realized this requirement and they started providing hosted applications. So now they are providing your application and data in the same location, like Google Docs, Office 365, and Power BI. I'm sure you all know about Google Docs. You don't have to download any software. It is totally online, right? So if you want to start a document, go like docs.google.com on your browser and write a document. It is get automatically saved in Google's own server. Okay. On the next device, when you just sign in, you'll still have the document, right? So now if you have a 10 devices, your data has been centralized and you have a data from any of those devices as long you have the right credentials to access the data. So products like Google Docs started revolutioning the markets. As hosted products like Google Docs started gaining a lot of traction, a lot of people started moving to Google Docs. So companies like Microsoft, which had Office sold on CDs, were forced to launch similar products. Then Microsoft launched a product called Office 365, which is also a hosted solution. Okay, so this is an evolution of software. We have first started the mainframe, then we moved on to the PC era, and now we are in post PC era. Okay, so next topic we are going to see about the traditional infrastructure. Okay, so we are just take a look at it. So what it takes to deploy an application on traditional IT infrastructure. So there are various layers in traditional IT infrastructure. Let's discuss that various factors. Okay, you must consider while deploying on this each and every layer. So the first and bottommost layer is physical layer. So this involves figuring out things like where you have to put your data center. It has to be in a good place. Okay, place is mean that it should not be a flood zone or an earthquake zone. Okay, so the data center should be secure. Okay, it should not be possible to physically break into a data center, right? So it should have a good power supply, if possible a power from two grids. Okay, we have to need a backup generator, we have to need a huge tank for a diesel storage, we need to have a cooling equipment. Once your data center is set up, then now we will have to buy and install servers in it, right? So connect them all with the cables, routers, and switches. Deploy a service on each and everything. Then you have to arrange staffs to maintain your data center as well. You have to hire network engineers and necessary security professionals. Okay. Then comes the low-level hardware. Physical layer allows us, like we will call the low level hardware resource layer. So most people think in terms of low level hardware resource. They will have to say 1 petabyte of storage capacity, but they might not look how many hard disk will be necessary to get those. Okay, or service will be necessary to reach that amount of stage, right? We have 1 Gbps link, okay, but they are not concerned about how many routers are present or what kind of network configurations have been done. Okay, so this is we having a lot of things in low level hardware resources. Okay, so then comes the low level software resources. Like low level hardware resource allows you to deploy low level software resources on top of it. Okay, so these are the software resources that are deployed used by higher layers. We generally don't use softwares directly. For example, databases. We don't use databases directly. It is almost used in conjunction with some applications. Okay. So similarly, the web servers or the application server. So these are there to support the application, not used directly. Most developers and testers think in terms of low-level hardware resources and above. Okay, they don't really care about the low levels unless there is a problem. If there is a problem, such as the database is slow, then they will dig into the lower levels and check if the network is a problem or machine is faulty. As long as the database is fast or the web server is fast, they don't really care about how things are laid. Okay, so then comes the application layer. So this is where we will develop and deploy our application. So this is where you ideally want most of your developers and testers spend their time. Okay, so they should not spend the time underneath. So this is the goal. All the focus and effort should be on your application. At the end of the day, this is what it distinguishes you from competitors. So this is what make Facebook and the Google Plus. Okay. So most of the users don't care about the architecture underneath the Facebook. Okay, they just care about the application that it runs. Might be Google Plus be a better application than a Facebook. Okay, but if it doesn't loads up, who needs a better application called Google Plus, right? So you can use a Facebook itself, which has been loading. And finally, there will be a users. Okay, so there are a variety of devices, PCs, which could be Windows, Linux, or Mac, or any variety of smartphones. Okay, so they might be geographically located in different regions. Okay, since this is a hosted solution. Okay, so this is all about the traditional infrastructure. Okay, so soon we'll discuss what are all the issues regarding this. Okay, so on the physical layer, we need to have a lot of capital upfront. They have physical limitations, and we have to have a good network engineers. Okay, so managing the networking of 10 servers can be handled by a single person, but networking of 1,000 servers is not an easy job. Okay, so you'll need a team of good quality network engineers who must handle not only the installation and the setup, also the maintenance and also the support. Okay, at the low level hardware resources, it is very hard to estimate your hardware requirement in advance. How many users you will have? How will they use your software? Okay, so let's make an example of Office 365. Let's say spell check is an expensive operation. Let's say Microsoft is launching Office 365. They don't even know how many users are going to use this. Okay, what is the average spell check run by a person once a document or twice a document? Okay, so depending on these numbers, their need for CPU and memory will be very difficult. Okay, they will never know until they launch the application. Another issue you will face is hardware becomes cheaper every month. Correct. So next, low level hardware resource layer, we have upfront licensing cost issue. So imagine you are a startup and you have to use Oracle. Okay, for a year you are going to be in development phase. But with Oracle, you have to pay the entire licensing fees from the day you are purchasing the software. Similarly, there are a lot of applications on the market where you have to pay upfront licensing costs. Okay, you will need a good software engineering team. It is easy for a maintenance team to manage few missions, but as of a size of a company grows, simple tasks like installation or patching work or updating can get tedious work. Okay, you need an experienced, dedicated team experienced in such tasks. Okay, then we are having the application layer, the last and final one. The problem is that you are tightly coupled to your geographic location. Okay, let's say you release an application in India, okay, but it become really popular in US. The US users might not get the best performance because of the latency coming from India. They will get a subpar experience. Now if you plan to move your application to US, then you have to start from scratch, finding a suitable place for a data center, then renting a place, buying the service or deploying them. The entire process you did it in India has to be repeated again. Okay, you never know when your application will become popular. Okay, take an example of your Orkut. Okay, you might have had an account on it before Facebook. Okay, some guys from Google developed this application called Orkut. It was so US centric. Okay, so at that point of time there are a lot of cities, okay, listed over there where you have to choose your home city. Surprisingly, okay, there is only US cities. If you are from other countries, then you have to choose only other option. But the story starts here. Surprisingly, the two countries where it become more popular. Okay, one it is in India, and another one it is in Brazil. Two culturally different countries, two different speaking languages, but around 70% of Orkut users base was from them. This proves that when you launch an application, you will never know where it gets going to get popular. Okay, so these are all the main issues with the traditional infrastructure. Okay, but the main story starts here. What if your infrastructure is not a core business? Okay, but you have to have a 24 bar 7 care to maintain your infrastructure. Okay, so now what you are going to do, the traditional IT infrastructure is there. So here we have a physical layer, the low level hardware, low level software, application layer, and the users. Okay, so until your application is working fine, users are never going to mind what is underneath or what is beneath there. Correct. So now what we are going to do, we are going to club all these IT infrastructure layers into one. Okay, so this is the famous image of showing pyramid of effort. Okay, so while establishing the physical layer, so this much of effort you're going to lay on it. Then comes your low level hardware, then comes the low level software, then comes the application layer, and how you are working for users is very very less. Okay, but the users is only point of which would make you to stand out from your competitors. Okay, so now what we are going to do is everything is going to be supported by the cloud. Okay, AWS is nothing but a cloud provider. Okay, everything is going to be supplied by the cloud, and you're just going to manage only the users. Okay, so everything will be managed by the cloud provider, and you are just going to manage the user alone. All right, fine. Okay, so this is what the cloud is all about. So traditionally we have this much of efforts have to be undergoing to make an application. Correct. So now what is a cloud computing? So the on-demand delivery of compute power, databases, storage, or the hosted application or the managed application, and all other IT resources. Okay, these are all being delivered through the cloud service platform. You don't have to install any software on your computer or laptop or on your pads. Okay, so instead we have a console, okay, which will run in any of those browsers. Okay, you can get access through the console to an internet with pay-as-you-go pricing model. So this is all about the cloud computing, on-demand delivery of compute power, database, storage, applications, and other IT resources through the cloud service platform through an internet with pay-as-you-go pricing model. Okay, so people might get different definitions from each and every websites which they are going to refer. Okay, so this is my point of view in referring. In short, the on-demand delivery of IT resources. Okay, so just the on-demand delivery of IT resources over the internet with pay-as-you-go pricing model. This will give you a suitable and the more easier definition. Okay, on-demand delivery of IT resources. Okay, the compute power, database, storage, applications, everything comes under the IT resources through the internet. Okay, through the internet with pay-as-you-go pricing model. So all of this, the definition, I'm going to explain you in detail coming forward. All right. So this is a Gartner's Magic Quadrant. So this will tell you. This is a graph like who are all the cloud providers over there. Okay, and how they have been performing. So we can see the leaders. Okay, we can see the neck players. Okay, so these are all the cloud providers, right? So in leaders category, we have AWS, that's Amazon Web Services. Then we have Azure, Microsoft's Azure. Okay, then we have GCP, Google Cloud Platform, which is from Google. Okay, then in the Nick players category, we are having the Chinese cloud, Alibaba cloud. Then we are having Oracle cloud. Then we are having Alibaba cloud. Then we are having Tencent cloud. Okay. So in the leaders category, all those companies are from main US based cloud providers. Okay. So in this channel, we'll be mostly seeing about AWS, Microsoft Azure, and Google Cloud as well. Okay. So subscribe here to follow more. Okay. So you'll get the videos more often from now on. Right. So introduction to AWS. So Amazon Web Service, right? So why it has been Amazon Web Service? Here you can look at it. Okay. So every other players they are having cloud at the end. Microsoft is Azure Cloud. Okay. Google is GCP, Google Cloud Platform, Alibaba Cloud, Oracle Cloud, IBM Cloud, Tensor Cloud. Why there is no cloud in the name of Amazon Web Services, name of AWS? Okay. So there is no name. Why? Amazon Web Service, they offer cloud-based products. Okay, we have seen everything. And now the main concentrate thing is these 3 points. Right. So what is the meaning of on demand? Okay, what is the meaning of available in seconds? What is the meaning of pay as you go pricing? So let's take an example from here. Okay, so now what you're going to do is you are the owner of a startup company. Okay, so this startup company, what they are doing is they are a photography company. Okay, you got a famous client. Okay, you have a famous client. Who can be the client? Any examples? Let's say Johnny Depp. Okay, so Johnny Depp was your client. Okay, so now what you're going to do is Johnny Depp is going to have a marriage next month. Okay, so you are expecting a huge number of celebrities for his marriage function. Okay, I mean a wedding function. Okay. So for this function, it's going to happen for 5 days or 7 days. Many events are going to take place, and there are many more celebrities are going to visit those places. Okay. So now your task is to not to lose any of those footage of any of those celebrities. Okay. So 5 days, and there are huge number of celebrities going to attend the event. Okay, so now what you have to make sure is at least you have to make sure 50 or 70 cameras for the 5 days. Okay, so all of these things you have to store it in some place. Okay, let's say you are estimating like 1000 TB storage space. Okay, if you are using a traditional infrastructure to store all these 1000 TB of data, right? So you have to buy how much number of, can you even imagine how much number of hard disk or how much number of pen drives you have to buy? Okay, it's been impossible, near to go. Okay, so now you are just a startup company, and you have been flabbergasted by this event. Okay, so now what you're going to do is, the cloud is there. Okay, AWS is there. So now what you're going to do is, you have wasted 1 month in searching for the companies outside. Okay, and tomorrow or in a week you are having the event. Okay, you have to be ready for that event. So now we are going to create an AWS account. Okay, on the next day of creating an AWS account, you can demand 10,000 TB of data you want. Can you even imagine this? On the next day, or on the next hour, okay, after 24 hours, there'll be a grace period for 24 hours after creating an account. But after that, when you need 1,000 TB of data, immediately you can get it. When you need a 10,000 TB of data, immediately you can get it. Okay, so that much of on demand the need is being sophisticated by AWS itself. Okay, so it is not like you have to wait for some time to get those storage space. It is just available in seconds. Okay, what you have to make sure it, only you should have a good internet connection to use this cloud. Okay, so also imagine a situation. Okay, so the same wedding event is going to happen. Okay, so you have made a footage of those 5 days. All the celebrities have been coming on. Okay, so you have filled up your storage space. Okay, like 1,000 TB of storage has been completely filled. So now Johnny Depp comes to you and says, okay, the photography skills is good, but I'm going to hand over the editing to someone else. You have to share the data what have been recorded in that event. Now you don't have any other way to go. You are going to give all your data to Johnny Depp. So now you surrendered all the data to him. Okay. Now all the data is with Johnny Depp. What about the AWS? Okay. You have told AWS like you need immediately 1,000 TB of storage space, and now immediately you don't need it. Okay. Will AWS going to impose any fine or any rules against you? Nothing. You are just going to pay for whatever you have used. Okay, so that is called as pay as you go pricing model. So introduction to AWS is nothing but on-demand delivery of IT resources over the internet with pay as you go pricing model. Okay, so we'll see this. This one definition is enough to explain the entire cloud. Okay, so whatever the service I'm introducing you to, you can compare with this statement. Okay, so this works fine with almost all of those cloud services. Okay, so AWS is a cloud provider, and cloud service is a different thing. I'll introduce you later. Okay, so what is a web service? Why does Amazon doesn't have a cloud in their name? Okay, so when AWS was being entering into the market, okay, so they are going to, what they are going to do is they are going to make their service available to the customer through an internet. Okay, what does this mean is it is a web service. Okay, so web service means Amazon is going to make a software. Okay, so that software will be available on the internet. With that software, you can get how many servers you want, how much storage space you want. Okay, this is the software, and that software is a web service. Okay, so the name called Amazon Web Services. So after the Amazon Web Services came into a market, it's like pretty 7 8 years the next cloud came in. Okay, can you even imagine? Just for 6 7 years, there is it's like a monopoly. Only one cloud provider was there, that is AWS. Okay, he was there entire time, right? So in 2006, Amazon became their IT infrastructure offerings, okay, to the businesses. That the process is called as web services, and now it is commonly known as cloud computing. Okay, so now AWS provides you the highest reliable, highest scalable, and low cost infrastructure platform in the terms of cloud. Okay, right. So, what are all those advantages of cloud computing? Right. So, trade capital expense with variable expense. So, what is the capital expense and what is the variable expense? So, capital expense means before starting your company or before starting an organization, you are giving your expense, right? So you have to see the floor or the space, you have to spend for the servers, you have to spend for the licensing cost, right? So that comes under the capital expense, the traditional way of doing it. Okay, so what do you mean by variable expense? Variable expense means the bill from cloud, okay, or the salary for or the CTC for the cloud professionals. Okay, that's called a variable expense. You are trading the capital expense with variable expense, which is very much less than the capital expense. Okay, so benefit from massive economics of scale. So what does this statement mean? Benefits from massive economics of scale. So when AWS was there, the cost was really high. Okay, when the other cloud provider, let's say Google came in or Azure came in, these are all they are the competitors in cloud. Okay, so to match their competitor, even AWS will lower that price. Okay, that is called as massive economics of scale, right? So the third one is top guessing capacity. Okay, so you are a startup with a photography company, and next time you will have a better client than Johnny Depp. Okay, so this time you don't, I mean, not better than the next Johnny Depp client. Okay, so this time you don't need to guess the capacity. Okay, so just go on with the flow. Think of your application. How can you work on that? Okay, stop guessing the capacity here. Okay, so this is the third point. Stop guessing capacity. And the fourth one is increased speed and agility. Okay, so whenever you got a new server, you have to find a space for that, you have to find a network equipment for that, then you have to configure that to work along with your application. Okay, so these are all the resources or the agility behind this. So you'll have an increased speed and agility. This is like getting a new resources are like one click away. Okay, so just click it and you will get a, have a resources to work along with your application. Right? So stop spending money for running and maintaining a data center. So you're not having a data, you are not owning a data center, so you're not going to spend money for the data center. Okay. So the last and final thing, go global in minutes. So this is an Orkut example. Okay. So your application might become famous anywhere around the world. Okay. But if you want to switch over to that region to seamlessly serve your customers, so that's become a tedious process. You have to start from the scratch. Okay, so either you can use cloud so that we can get travel to global data centers of AWS cloud providers data center in minutes. Okay, so we'll see this when you are moving to AWS console, how to go global in minutes and all. Okay, so these are all the six advantages of cloud computing: trade capital expense for variable expense, benefit from massive economics of scale, stop guessing your capacity, stop spending money on running and maintaining a data center, go global in minutes. Right? So next, the attributes of cloud computing. Okay, so elasticity or high scalability, self-service, pay-per-use, fully virtualized, use HTTP, I mean REST API or SOAP API. Okay, so what is this all about? Elasticity means the right? So elasticity means cloud providers must allow all their users to quickly provision and deprovision their resources. Okay, so whenever required, let's say you have a e-commerce site and you need 20 servers to support your traffic during peak hours of a day, but at the night you don't have that much traffic. Okay, you just need only 2 or 4 servers running. Okay, so cloud should give you the ability to change your fleet size from 20 servers to just 2 servers. Okay, so for this to happen, you need to automatically scale up and down. Okay, so if scaling up and down was manual, it becomes very tedious process. Okay, so it will hamper you if your cloud provider charges minimum 24 hours of usage. So each time you start a server, then e-commerce site will just mention, okay, it will not be an elastic, as there is no financial benefit in this. Okay, so next, high scalability. Okay, so providers must allow you to scale up and down at the internet scale. Okay, so in today's world, it is uncommon for any new application or a service to get millions of users within few days. So if your application is being hosted on cloud, and the provider should be able to give you enough resources to serve you the traffic. Okay, so provider should not limit you for very low level of service and just few TB of storage. Okay, so then they cannot be considered as a cloud service itself. Okay, so then comes the self-service. Cloud providers must allow self-service access to their services. Okay, so that you should be able to sign up in online itself by providing your credit card details and your ability to access your resources at any point of time. Okay, so customers should not be able to request and pay their desired services without the intervention of human operators. Okay, the pay per use, you know. Okay, you know already what is mean by pay per use. Then comes as fully virtualized. Okay, we can also call it as fully automated as well. Okay, so what this means is you don't have to get actual access to physical resources itself, but to a virtual appliances on top of it. For an example, storage, you will get not actual physical access to the hard drive, but you are having a virtual layer on top of it, and the servers provided are virtual instances. Okay, so this allows sharing by multi-tenant architecture, where a single physical user could be hosted as a virtual service from two different clients. Okay, and the last and final thing, cloud services have to use internal protocols and technologies. Okay, let's say you have an application that lets you upload backup files and download them whenever needed. Okay, you visit the application, browse for the file, and then click upload. Now the data gets stored on same centralized server whenever you want to download. Okay, you select from list of files, click download. So in addition to a manual driven approach, cloud services have to give access to the application with help of some of the APIs, which is called as REST API or SOAP API. Okay. So nowadays people stopped using the SOAP API. REST API has been most common thing, or any other APIs you have to use. Okay. So this is not a big deal. So let me explain these attributes of cloud computing much more simpler way. Okay, elasticity means your entire application should be elastic in nature. You should be able to use 20 servers in a single time or 2 servers in a single time. It should be elastic. Okay, whenever you're needed, your servers or your architecture should be in heavy level. Whenever you don't need it, you can make it as a small thing. Okay, so that is mainly correlated to pay per use also. Okay, whenever you are using 20 servers, pay only for 20 servers. Whenever you are just using 2 servers, pay only for the 2 servers. Okay, so highly scalability. Okay, so highly scalability means now you are having just 20 server, but if your user scales are rising exponentially, you should also be able to rise exponentially. Okay, and that is called as high scalability. So imagine on the next week itself, you need to have 20,000 servers on the go. Okay, so that is the high much of scalability that should be provided by the cloud computing itself. So if a cloud provider is telling you, no, you have to use the 20 servers only, then means they are not going to be a cloud provider. A cloud provider should satisfy all of those attributes. Okay, it should be a self-service. There should not be any man between you and the cloud service provider. Okay, it's just an online portal giving you a credit card and you're getting your services back. Okay, you are just paying only for the services. Yes, right, fully virtualized. Correct, you are using going to use only internet to access those things. Okay, that's not a physical going to be hardware, it is a virtual hardware. Okay, virtualized environment on top of the physical hardware, you're just going to use it. Yes, you are using the internet and you are using the HTTP, REST or SOAP API. So with these attributes of cloud computing, you can refer with the definition of cloud computing. Okay, so delivery of IT resources. Okay, on-demand delivery of IT resources, which means it should be elastic in nature, it should be highly scalable. On demand. Okay, on-demand delivery of IT resources over the internet. Over the internet tells you it should be a self-service thing, okay, with the only the internet, and it should be fully virtualized, and it should be HTTP, REST API, or SOAP API. Okay, and the final thing, pay as you go pricing model. So it means pay per use. So they're starting with an definition of cloud computing in 6 different points. Okay, so on-demand delivery of IT resources over the internet with pay-as-you-go pricing model. All right. So next we are coming on cloud segments. So what is this cloud segments is all about? Okay. So any idea what is this mean? Cloud segments means? No. Okay. So first we'll discuss about this IaaS. Okay. So IaaS means infrastructure as a service. Okay. So the platform as a service, PaaS, and software as a service, SaaS. Okay. We are now going to understand the features, the difference, advantages and disadvantages for having various cloud segments. Okay, so these are the three main cloud segments, but we are having many more on this. Okay, but in this session we'll be discussing only these three cloud segments. Okay, so let's discuss about the SaaS first. Okay, SaaS means software as a service. Okay, where your application and data are both in the same place. For example, Google Docs. Okay, so any service which has its application and data in the same location, or which provides you only API to interact with. Okay, example, let's say your company wants to deploy a human resource management system. You have options to buy it as a software, deploy it on an infrastructure, okay, or just use an online version on it. Okay, everything will be a SaaS application that provides you to configure the application. Okay, whenever a new employee joined, a user record is created for him in the company's active directory. Okay, so the corresponding user record will be gets created in HRMS also. Okay, I mean human resource management system also. Okay. So moreover, as number of employees in an organization grows, you don't have to worry about it. Okay. The scalability part of application, okay, it has been inbuilt in the SaaS layer itself. Okay. So that's we are the next is the completely different from SaaS model. Okay. IaaS. Let's say you are designing an infrastructure for any e-commerce site. Okay. So what you are going to do is like how your infrastructure will be looking like. You would have a data center, you have a load balancer, some of the servers will be running your code. You have a database, some storage will be there where the product images have been stored on. Okay. In IaaS, you are going to select and handpick each of those components in cloud. Okay, so until now we are talking about the traditional infrastructure like having a data center, load balancer, and all. So after this, in IaaS, we are going to select and handpick each of those components. Okay, you can decide what kind of storage you need. Okay, what is the best product? You can potentially go for any AWS services or Microsoft services. Okay, you are responsible for figuring out how different components interact with each other. Okay, so each of these services is like behaving like an individual block where you can pick and choose, where you can plug into a service to the power your application, and these are called as infrastructure services. They provide you with building blocks of core infrastructure, okay, and it is just like storage and execution for you to design your infrastructure. Okay, and the last and final one, platform as a service. So platform as a service, how it is different from IaaS? Here is you just have a control of simply the location for your application. Okay, you don't get to choose the building blocks. Okay, so in AWS we are having an example for PaaS. In Google also we are having an example for PaaS. We'll see that uh, in the next coming upcoming videos. Okay, so if you want a storage, you can that PaaS offering will call the API internally. Okay, that will use the cloud storage internally, and it will store your data there internally. Okay, what you're going to take care about is only the code which are for your application. Okay, so get only a code for your application, and remaining everything will be handled by the PaaS offering itself. Okay, so now we have these cloud segments called infrastructure as a service, platform as a service, and software as a service. Okay, so now we are going to see what is the foremost difference and the advantages and disadvantages in using all of these things. Okay, so we'll now open a new tab and we'll just type SaaS, PaaS, and IS graph. Okay, so let's make this. Okay, so let's open this image. Right. So here you can find the example of infrastructure as a services. Okay, Amazon Web Services, Google Cloud, Microsoft Azure, and IBM Cloud. Okay, so Google's App Engine is nothing but a PaaS offering from Google Cloud. Okay, so similarly we have a Red Hat OpenShift or Heroku. Okay, so in SaaS offering we are having Dropbox. Okay, the famous thing, and we are also having Jira as well. Okay, so we'll go for the graph now. Where is the graph? Oh my god, where's the graph? Right. So the key benefits of SaaS, PaaS, and the IaaS. Okay. So IaaS have a greater flexibility. Okay. Also, it has a greater responsibility. Okay. You can choose whatever the storage type or server type or what database you want. Either all the components you can choose. Okay, here you have a greater flexibility. The flexibility comes with greater responsibility. Okay, SaaS has very little responsibility. Okay, where you can just able to decide your username and you can just change the color of an UI. Okay, other than that we don't have any other flexibility. Also we don't any other responsibility as well. So in Google Docs, are you going to manage anything? No. In Gmail, are you going to manage anything? No. So these are all the SaaS offerings. So PaaS, we are having somewhere in the middle. Okay, so PaaS is like you have some of the responsibility, like in terms of code, but you don't have to maintain the infrastructure here. Okay, so in SaaS, we are not responsible for installation or maintenance requirements and all. Okay, we just have to create an account and start using the software. Okay, there is no upfront or license costs here. Okay, SaaS gives you the ability to access the application from anywhere else, just with an internet connection. All right, so next what we are going to see is, so okay, the next topic is, right, pizza as an example. Okay, so we'll just see this pizza as an example. Pizza as a service for cloud. All right. So consider you are having a traditional infrastructure here. Okay. So what is this? Okay. So let me close this one. Right. So imagine you are using a traditional or on premises. Okay, in early 2000 period. Okay, so that's the traditional one. Then the IaaS offering, infrastructure as a service. Okay, so then the platform as a service. Then the software as a service. Okay, so how it is being correlated with right now. Okay, so imagine pizza with your application. Okay, so traditionally, if you are making a pizza, it's like making at home. Okay, you are having way more flexibility. Okay, you can just choose whatever you think you want. Okay, so what kind of dining table you want, what soda you want, whether you need electric or gas. Okay, or what is the oven you're preferring, how much fire you need, firewood. So what is the pizza dough you want, what's the sauce you're preferring, what are your toppings. Okay, either you need a cheese or not. Okay, so these are all the flexibility you are having. Okay, in traditional thing you can select whatever you want, but there comes the responsibility as well. Okay, you are responsible for the dining table. Okay, so it should not be affected by any termite. Okay, the soda should be in the manufacturing limit. Okay, it should be consumed like you understand, right? So it should not be the gas should be readily be available. Okay, so the pizza dough should not be ruined. Okay, it should be good, sauce should be good, toppings you are being ready, and cheese also you have to take care. Okay, so these are all the flexibility and the responsibility considering the traditional on premises. But if you are handling infrastructure as a service, okay, infrastructure as a services, the vendor is going to manage you something. Okay, cheese, toppings, tomato sauce, and pizza dough is being given by the vendor itself. Okay, it's like making a franchisee. Okay, so it's like making a home, and this is like a franchisee. Where here you are responsible for dining table because you are taking it and baking it in your home, right? So dining table is your preference. Soda, gas, oven, fire is your preference. What you can get is in a packet. Okay, you can get a pizza dough, just bake it and have it. Okay, these are the infrastructure as a service. So platform as a service is, okay, it's been delivered to you. Okay, you just have to eat it. Okay, so the dining table, soda alone you have to take care. Okay, everything is been taken care, and the pizza has been done, and it also been delivered also. Okay, the vendor manages everything in platform as a service. So the finally there come it as software as a service. Okay, so here it is like dining thing. You have to go into a restaurant, and everything is being managed by the vendor itself. Okay, you're just going to eat it, right? So this is the basic level comparison. This is not needed anywhere. This is just for your understanding alone. Okay, so pizza of service, what it is and all, they are not going to ask you anywhere else. Okay, this is just for your understanding. Correct. So we'll move. Okay, the pizza as an example is being completed. So next comes the deployment model. Okay, so deployment model, we are having three deployment models. Okay, the community cloud is also there, but it's to be missed out. So the first thing is public cloud. Okay, it's been easier to understand public cloud means. Okay, so public cloud means cloud providers like Amazon, Google, Microsoft, or whatever you see in the Gartner thing. Right? So they should be able to provide you the services to any organization or any entity. Okay, if you are ready to pay amount for those resources you are consuming, then it should be readily available for you. That is called public cloud. Public cloud means you should have a credit card, go sign up for the account there, and then start using it. Okay, that is called as public cloud. So private cloud on the other hand is operated and maintained within the organization. Okay, so let's think about some of the reason why this came along. Okay, a while ago there have been server done for some of those Fortune 500 companies. Okay, where the average CPU utilization for their hardware resources were being measured. It is found that less than 5% of their hardware are being completely utilized. Okay, so the research realizes that it's because of two factors. One is the cost of overestimating the hardware need. Okay, uh, so it's like needed, right? So we cannot get the risk of underestimating. Okay, no one can get fired because of overestimating the hardware needs. But if your system crashes due to underestimating of the hardware needs, you might be in trouble. So most of the IT professionals are on the side of overestimating the hardware resources. The second reason is procurement time of your hardware. Okay, so this is usually taking months in most of the organization. From time to purchase and the time taken for the delivery, networking, software deployment for the time they are available. Okay, it's going to take you at least a month. Okay, so the first you have to effort to tackle this is hardware virtualization. Okay, so this is being done under this virtualization. If they are able to get their servers or their storage space readily available only for those particular members of the company, and then that is called as the private cloud. Okay, so before coming to hybrid cloud, we are going to see community cloud. Okay, so community cloud is a private cloud also, but it is being managed by two or three companies altogether. Okay, so if you think about like cost in terms of private cost cloud. Okay, so the cost is being divided by all the two or the three companies so that they are easily able to manage their own private cloud itself. Okay, so then it comes the hybrid one, where you the people usually use different kinds of cloud at the same time. And that's why it's called as hybrid cloud. One, they're going to use the public cloud, and the other they're going to use the private cloud. So they'll be having all the important data within themselves, and they're just going to analyze it on the public cloud. So this is the hybrid cloud model. Okay, and the next thing, deployment model. So either you can have all your both data and application all together in cloud. Okay, or else you can use the hybrid model, both cloud and on premises, or at least the on premises. So this is directly linked between the deployment models as well. So cloud is using the public cloud model, hybrid is using the hybrid cloud, and on premises is using the private cloud. Okay, so this is all the deployment models. So if you are concerned about using getting certifications, so in AWS we are having foundational, associate, professional, and specialty level certifications. Okay, so foundational level certificate is cloud practitioner. For this, you have to have 6 months of fundamental AWS cloud and industry knowledge. Then we are having associate. For this, you need to have 1 year of experience in solving the problems. Then we're having professional level certificate. Okay, so try to get this cloud practitioner. Okay, if you are a fresher working in a company, then after working in a cloud, you can aim for the solution architect. Okay, so then you can go for solution architect professional, or system sysops administrator, or developer associate, and then you can go for DevOps engineer. So after completing one particular path, like app cloud practitioner, then solution architect, then solution architect professional, or cloud practitioner, sysops administrator, DevOps engineer, or cloud practitioner, developer associate, DevOps engineer. Okay, then you can go for the specialty. Okay, advanced networking or big data or security or machine learning or Alexa, skill builders. Okay, so these are all the certificate parts for considering AWS. Okay, we are also having certifications for Google Cloud as well. Okay, we are having it for Cloud Digital Leader. Okay, so we are having Associate Cloud Engineer. Okay, so Cloud Digital Leader has been foundational. Okay, you don't need to have any cloud experience here. Then the associate is recommended for 6+ months hands-on experience with Google Cloud. Okay, as a associate cloud engineer. Next, we are having professional cloud architect, professional data engineer, professional machine learning engineer, and you can see in the slide itself. Okay, professional cloud DevOps engineer, professional workspace administrator, cloud developer, cloud network engineer, cloud security engineer. Okay, then heading towards AWS region. Okay, what is AWS region means? AWS region, it is a physical location in the world, okay, where we are having multiple availability zones. AWS region is a physical location where it has multiple availability zones. Okay, don't care about these large topics. Okay, so we'll be having a discrete everything in the coming slides. Right, so AWS region is a physical location in the world where it has multiple availability zones. So what is an availability zone? Availability zone is nothing but it has one or more data centers itself. Okay, all these data centers will have redundant power, they will have networking capacity, and they have network connectivity. Okay, all these data centers in separate facilities. So what is a region? Region is a physical location in the world. It will have multiple availability zone. Okay, what is availability zone? It will have one or more data centers, readily available data centers. Okay, so in other words, right, so one or more data centers together, they are called as availability zone. One or more availability zones together, they are called as regions. Okay, so these availability zones offer you the ability to operate production level applications or databases which are highly available, fault tolerant, and scalable. Okay, that should be possible from any single data center. Right, so we'll see forward. So let's see the global infrastructure. Okay, okay. So you can just go for type for global infrastructure AWS and come into the first link. Okay, when you get this link, you can just have a look on infrastructure of AWS. Okay, so it's been loading slow. Okay, let's see global infrastructure. Global infrastructure AWS. Okay, so the first link AWS global infrastructure. Okay, so this is the site for global infrastructure where we are having 33 launched regions. Okay, all these each and every region have multiple availability zones. Okay, so 33 regions is having 105 availability zones. Okay, we'll see the map itself. So this is the global map where you can see all those regions. Okay, if you make your cursor on top of it, okay, you can just see what is the name of the region. Okay, when it has been launched, how many availability zones are there. Okay, so regarding local zones and wavelength zones, we'll discuss it later. Okay, so in this for the North Virginia, this is a government cloud, US East. Yes, US government is using cloud, which is for AWS alone. Okay, this region is specially for US government. Okay, you don't have an access for this. Okay, it's in Ohio. It's Canada Central. Okay, you can come here for Canada West. Oregon is there. Northern California. Okay, this is also a government cloud. Let's come to some Asian parts. This is a Hyderabad region. This is a Mumbai region. Mumbai region was launched in 2016. Then coming to Middle East countries, we are having in UAE, we are having in Bahrain. Uh, in Saudi Arabia, it's coming soon. Okay, we are having in Tel Aviv. What is the Tel Aviv means? Any idea, guys? The capital of Israel. Okay, Tel Aviv. Then we're having it for the European regions: Spain, Ireland, London, Paris, Zurich, Milan, okay, Stockholm, right? So you can also see the Japanese regions and Chinese regions as well. Okay, so this is the global infrastructure. Okay, so let's come back to the slide and we'll start this. Okay, so this is the link. I'll paste this link in the description box below. You can go for this link and you can view. Okay, or else you can open your browser, search for global infrastructure space AWS, hit on the first link. Okay, you'll get to see the page. Okay, so there are factors going to be there to choose the region. Okay, so the first and foremost thing you have to see when choosing a region is the complaints. Okay, so the complaints is like when you are working for an American MNC. Okay, so there is something in US stating like their citizens' data should not reach the other soil. Okay, so the name is the Patriot Act. Okay, so the citizens' data should not reach other countries' data centers. So that's a compliance there. So if you are going to working for an US based MNCs, then there is a complaints like this. Then you have to choose only AWS US regions. Okay, so similarly, European Union is also having the same complaint. Their data should not reach the other country data centers. Okay, I mean non-European data centers. Okay. Also, the second factor is cost. Okay. So why is there is a difference in cost for a single company from ranging from US to India or for uh, any other Asian countries? Why is there is a difference between a cost? Okay. uh, in terms of this, you can also ask yourself, okay, so here I intend you to pause this video here. Okay, pause this video and just think it of which will be the higher cost and which will be the low cost region. Okay, so stop the video and think of which is the high cost region and which is the low cost region. Any ideas? Any ideas? Which will be the high cost region? High cost region. Okay. So how many of you think is it is a high cost region? Is US or India? No. Okay. So actually, the cost of US regions is pretty much low. Okay, because you can see the top three cloud players like let's say Amazon or Google or Microsoft, their home turf is US. Okay, their home turf is US. Also there are many places available in US region in US nation itself. Okay, they can get a place for data center readily in a low cost. Okay, but imagine getting a place for a data center in Tokyo. Okay, it is far impossible, right? So people like people itself, they are having an staying in very low space. Okay, so imagine building a data center up in Japan or Tokyo. Okay, it's been hard to find a place for this. Okay, so the real estate price along with maintaining the data centers comes into a picture here in terms of cost. Okay, so the high cost regions will be the Tokyo or the Middle East regions. Okay, and the low cost regions will be US region. Okay, so where do you think India fits in? It's a high cost or low cost? India fits somewhere in the middle. Okay, so it's not a cheaper one or it is not a very high prices. Okay, and the third one is a latency. Okay, so let's say you are going to start your next Ola or next Uber, like or any next Mintra. Okay, targeting Indian audiences. Okay, if you are choosing an Indian audience as your target and now you're going to select US regions, then that's not going to be a right option because all of their users data packets are going to travel the entire world, okay, and then come going to an application, right? So this in terms will reduce your application speed. Okay, so you should also consider this while selecting a region. Okay, so latency means you should not even only see the physical distance alone. Okay, so in terms of this, I give you an example. So if you take India as an example, which is the closest region, I mean closest nation networkly. Okay, in network space, which is the closest region, closest nation for India. Any guess? It's not a Sri Lanka, it's not a Pakistan, it's not a Myanmar, it's not a Burma, it's not a Nepal, it's not even China. Can you think which country? It's not a US, it's Singapore. Okay, so Singapore has been heavily connected with India through underwater cables. Okay, so you can even see in a news or browse in a Google stating from connection from Chennai to Singapore. Okay, so the latency between India and Singapore is been very less. So people might choose Singapore region as well to host their data for Indian users. Okay, so lots of Chinese gaming developers, they're choosing Singapore region as their home turf, okay, to serve the Indian customers. Okay, the last and final is service and features. Okay, you guys all guys know, like if they are going to introduce a new service or new feature inside, okay, let's say a beta program. Okay, so they'll just introduce it to few users or few regions. Okay, so if you want that particular service or particular feature, then you have to go into choose that particular region. So the factors to choose a region includes compliance, complaints, cost, latency, service, and features. All right. So let's go for the next one. So consider this as a world map. Okay, and AWS cloud is all where. Now these are all the US regions, EU regions, and an Indian region. So now we are going to take Mumbai region as an example. Here I'm going to show you two availability zones. Okay, so now what you're going to do is you're going to develop an application and set it up to the world. Okay, you are creating a new server that your application is being hosted inside a server. Now what you're going to do is your application got famous. Okay, it's got a most hits, a number of users have been increased. Okay, so after this what you're going to do is you're going to increase the number of servers to handle the request for your users. Okay, so this is called as scaling. Okay, so there are two types of scaling. One is vertical scaling, another one is horizontal scaling. Okay, so vertical scaling means making a machine small to big. Okay, if smaller machine cannot be able to handle the users, you're going to make the machine bigger to handle the number of users. But this is not recommended. Why? The point of contact of failure is very high and it is very risky in having a one single mission. Okay, so that is why every time we are going to perform horizontal scaling. Horizontal scaling means the same size of mission being introduced another one. Okay, if one mission is not going to handle your users traffic, another one mission will come. If two missions not able to handle, three missions will come. Three missions not able to handle, four cannot handle five. Okay, so in this way, we are having five different missions in a single availability zone. Now, if something happens, okay, oh my God. Okay, so if something happens and your availability zone goes out, okay, so what will happen? Maybe a terrorist attack, or maybe any natural calamity, or any disasters happen. Okay, now your availability zone is been gone. Okay, so now what will happen is you are out of the game. Okay, your application is out and you cannot do anything here. So if you're doing this, you're out of the game. So instead, what we can do is we can do like this. Okay, so the first server in zone 1 and the second server in zone 2. Third server again going to come to zone number 1. Okay, fourth server will be going to zone number 2, and fifth server will be coming to zone 1. If sixth is being introduced, it should be in zone 2. Okay, we are separating the resources here. Okay, now if availability zone 1 goes off, availability zone 2 is there, that will be able to serve your customers. So after this incident, within a minute or two, couple of minutes, you can introduce many three more servers in availability zone 2, and you can have your application hosted readily for your users. Okay, so now it takes turns. Okay, entire Mumbai region is being failed. Now what will happen? Now you should have some backup available readily here in a higher region. Okay, so here factors for choosing a region doesn't comes in a place. Okay, but you have to choose the compliance. Okay, latency and price will not come here. Okay, compliance and service you have to choose, but cost and latency doesn't come here. Okay, your application has to survive. For that you're going for the other backup region, right? So we'll be moving forward. Fault tolerance and stability. Okay, so each availability zone is designed as an independent failure zone, which means one availability zone has been disaster or gone, it will not affect the other availability zone. Okay, imagine if one all the availability zones are connected together. Okay, all the availability zones are connected together. If one availability zone is failed, means every availability zone will also be starts failing, and that is called as cascading failure. Okay, so this is why what they're doing is availability zones are physically separated within the metropolitan region. Okay, if Mumbai is being chosen, one will be near a sea level. Okay, other will be in somewhere around near the mountain. Okay, or in the plains. Okay, why it has been happening? If tsunami hits Mumbai, it should affect only the shore availability zone. Okay, not in the mountain region. Okay, so somewhere else your availability zone will be in a good way to serve the traffic to your users or the customers. All right, so then come for edge locations. Okay, so this link also I will post in the description. You can go and check this edge locations. Okay, so what this edge location actually means, imagine you are having a Mumbai region. Okay, now you are having a server in Mumbai region. Okay, your application is doing pretty good, and it's also attract many users for your region. Okay, people from all over the world started using this, started seeing your server. Okay, so imagine Indian Premier League is being hosted by your server. Okay, so everybody is hitting your website to see the scores from all around the world at the same point of time. Okay, so what will happen for users from American or from European regions? So they will face the internet bottleneck. Okay, so they will feel the loading one, and they will feel the internet bottleneck here. Also, you are the your server is going to give the data for each and every user. Okay, so this will also attract bill for AWS. Okay, so billing thing we'll see later after some videos. Okay, so billing you don't need to worry, but here they are facing an internet bottleneck. So how to avoid this? Okay, so we are going to use edge locations. Okay, so edge locations are nothing but ISP's data center. So what is an ISP? ISP is nothing but internet service provider. Okay, internet service provider is an ISP. So these ISPs, like let's take for an example, Airtel, okay, or some other internet service providers. Okay, so they will have a data center there. What AWS do is they will have AWS own infrastructure in ISP's data center. Okay, so why they are doing this actually? So when the first user, okay, hits the sorry when the first user from US regions is hitting the server, okay, so they will get the data through an internet service provider. Correct, you understand this? A user from US region, if he hits your data, he has to come through an internet service provider to reach your server. Okay, so what this server will do, it will not directly give a data to the user. This server will transfer the data to an internet service provider. From internet service provider, the person is able to get the data. While achieving this connection, okay, while achieving this connection, the data which is being received by this user will be cached here in this location, and this location is called as edge location. Okay, so when the second user comes in, he doesn't need to come to the server. He can get the data from here itself, from a cached data. This works similarly for South America or for European regions or for Russia as well. Okay, so they need to, each and every user, they no need to come to your server to to see the internet bottleneck. Okay, so either the other user will stop in the edge location itself, where they will get the data necessary for them. Okay, so the data will be cached here. So I repeat, when a person from US regions hit your server, he has to come through internet service provider. Correct, so he will come through internet service provider, he will reach your server. The server will do what the server will do. The server will give a data to the user through internet service provider. While this process happens, the data has been stored in the edge location. Okay, I mean, it is cached in an edge location. So when a second user comes, he will not come to our server. Instead, he get a data from edge location itself. Okay, so the second user will not feel any internet bottleneck, and for him the internet will be very speed. Okay, so that is why they are using edge locations. Okay, so let's move on. So this is AWS regions, what we have seen some time before. Okay, so this is a region, and okay, and coming soon regions are also being listed here. Okay, so this is for Azure regions and Azure's edge locations, which has been highlighted in red is an Azure's edge location. It's blue, it is in data centers. Okay, so what is this dotted line? What is this dotted line? All the Azure regions has been connected with high-speed fiber cable net. Okay, why we didn't see anything in AWS? Why we didn't see anything in AWS? Okay, so it's Google's cloud network. Okay, so also you can see this Google's network. Okay, all the regions has been connected with high-speed fiber cable with Azure as well as in Google Cloud Network. Okay, so these are all the regions. Okay, the black color are the regions, and we can also see the edge locations as well. Okay, so and this is the end of this video. Hope you enjoyed this one. Okay, so we'll meet further in the next video regarding with AWS, also with GCP as well. Okay, so thank you very much. Thank you.